In this episode, you're going to learn about real-time and enterprise data collection for IIoT, plant flow to cloud integration, integrating structured and unstructured data, industrial data lakes, IIoT connectivity technologies, real-time metrics tracking, OEE, the application of machine learning at the factory floor, and operational intelligence using the digital twin. My guest to help impart that knowledge is Mark Taccolini. Mark is currently the founder and CTO of Tatsoft, which is a platform developer for real-time factory floor data monitoring, SCADA and HMI systems, distributed data aggregation, and visualization tools. He previously served as the founder of Unstructured, a provider of HMI and embedded intelligence device software for the automation market, which was later acquired by Invensys. He was also the co-founder of Unitech and Unisoft, which specialize in the design and development of software systems for industrial applications. Welcome to the Fourth Generation podcast here on Industry40.tv, which is a series of weekly interviews designed to help you learn IIoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this podcast interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kutsai Mandi Teresa. Now, here is my conversation with Mark. Okay, Mark, thank you so much for coming to the show, and it's good to have you today.
Thanks for having me.
Okay, yeah, so we'll jump right into it. So today, really, I want to speak to you about the process of putting together an end-to-end IoT analytics system for a plant flow, which really begins by collecting data. And primarily, we've got two sources of data. We've got your real-time data from PLCs, sensors, and your SCADAs, and we've also got enterprise data from your ERPs. So I want to speak to you first about the real-time data. What's the best approach for collecting real-time data for IIoT?
Well, one thing that the factory floor that's unique, that's on the IIoT, the industrial IoT, is the amount of data and the frequency of data is typically higher than a traditional IoT if you compare with home automation or even some medical devices. So you need to have a good infrastructure on premises, on the sites. Some things like IoT gateways or edge devices that will be able to connect with those controllers to do some pre-process of the data, and some cases even running some analytics local and send up only the data that needs to go to the cloud. So one difference for that kinds of automation, you have more in-premises at factory edge devices. When you compare with an IoT solution, that's not industrial. That's one major point to consider.
Oh, okay. So now, as far as collecting data from enterprise systems, what sort of connectivity standards should one look at using to collect data from all these ERP and MES systems to integrate it into an IoT system?
What typically you should do, to be clear, we have two connections, one down to the factory and one up to the ERP. Down to the factory, I believe we're going to talk a little bit more later in this podcast, so I'll save that for later. And upwards, typically you have just exchange standard XML messages. Many systems like SAP and Oracle, because they try to work very strict on the security. They have APIs to connect direct to the systems, but in the practical life, you are not allowed to. Because many of those ERPs, they have so many restrictions that need to go through to be able to connect directly. So what does happen typically, you work with the company So they create standard interfaces for you to access data. Most of the time, you don't connect directly inside the ERP database. So they define data exchange using that format called XML, or in some cases, even text files. So we have a very specific and delimited interface to the ERP.
Okay, I see.
And that's very interesting because, of course, we have very advanced interfaces that we could connect directly and do everything, grabbing the data. But for security, the interface is much more delimited. So when you do that kind of project, you have lots of interactions with the corporate IT.
Okay.
So you do the project on your side, and they do a little project on their side, isolating the data you need to exchange.
Okay. All right. So when you finally get like that data, there's some instances where that data might have to end up in the cloud, or some kind of private cloud system that you may have. What's the best way of integrating between the plant flow data and the cloud infrastructure?
There was a research from a few manufacturers that they found out that for industrial applications, around 90% of the data and the transactions still happen on premises. Because we have the sensors, we have the physical equipment, you have the operators. That's lots of things. Even you have a cloud system, there are lots and lots of transactions that are still happening at the factory. And in fact, they vary little depending on what person you talk, but there is a more or less accept number that the number of transactions, even when we have a cloud system on the factory, is around 90% of the data is still remains on the premises on the factories. So the big key selection when you put your cloud infrastructure is to make sure your applications running on the clouds have a very easy integration to consume the data that is still on the factory. That's another difference for the industrial clouds, because in some applications, like you're managing the swimming pool temperature, you publish everything to the clouds, or you are managing your house security. You publish all the information, 100% of the information to the clouds. When you're deploying on your cloud solution to the factory, you need to have the cloud tools to be able to go to the data silos in the factory when they need analytics or when they need a deep dive on that data. Because for the factory, with the PLCs and all the information that's happening there, you cannot really go to a more simple cloud environment. Oh, let's send everything to the clouds.
Yes.
So the key point for that is to have the system flexible enough that some data and some calculation is happening only on the clouds, but that system can connect in real time with the factory to get additional logs, additional storage as needed for the analytics.
Oh, okay. Yeah, well, that's interesting. Now, what about a situation whereby you've got structured and unstructured data? You know, like you've got some data that is being collected using your manual paper-based maintenance records and your shift reports. How does that then get integrated with the other form of data into one big repository?
Yeah, what was happening is that if you go 20 years ago, most of the data was saved in very simple way, like just tables. And the SQL databases, they were very the schema was very strict. You knew exactly which columns you had. So it was very, very restricted. And one thing that did happen 10, 15 years ago was that object-oriented databases that many of your listeners heard about, like MongoDB or object-oriented modeling, that you can have any kind of unstructured data very easily. So for instance, if you're doing a database for customers in the traditional table model, you need to have all the fields: address, phone number 1, phone number 2. If you go to the object-oriented model, you can have anything. So you can have one address, you can have 10 addresses, or you can have personal data for that customers. And each customer, they can have its own set of fields. That's the object-oriented. And your question was great, because when you try to merge those two words,
Yes.
could be quite complex. But one thing that started happening in the last few years that's recent, most of the SQL databases, and the key example I'd like to give you is the Postgre database.
Yeah.
They're starting to allow to have in the tables some unstructured data also in the same database. So one thing that was happening, like many times happen on the evolution, we have that table very structured, and then the people went crazy to have completely unstructured data. Now we are finally getting back to the middle.
Yes.
That most of the advanced SQL solutions from Oracle, from Postgre, they still have their more plain tables, but they allow you to mix some unstructured data, that you have one or two key fields that are structured, like the email of the customer,
Yeah.
but to allow to aggregate unstructured data against that key link on the same database.
Okay.
So the good news for that was really a big problem a few years ago. But if you go to some solutions that Oracle, Postgre, and some other providers they have, you can manage on the single store both data. So the SQL guys, they make their schemes a little more flexible.
Yeah.
And the unstructured guy, they understood that you need to have at least some keys standard.
Yeah.
So the date's not really completely crazy. They put some little keys, and doing that, we have that combination of standard SQL tables and object-oriented model in the same data store nowadays. So
Okay.
that's much, much more easy to store. There is still a challenge there, because the databases, the Postgre, the Mongoose, they can store both structured and unstructured data. But some old applications, okay, the data's there, but they struggle to consume. So the market for visualization, for dashboards, for BI, it's growing like crazy now.
Yeah.
Because they solve the problem to store the data, but to do the applications around the data, a new generation of applications and tools is emerging, because the software that we had in the past
Yes.
could not handle that flexibility.
Oh, okay. Yeah. Well, you mentioned the fact that 90% of the data is really on-prem. And now, given that the volume of data that gets generated in a typical factory, like some factories I've heard that they can generate up to like terabytes of data per hour. So does that require some kind of special storage, some data lake?
Yeah, definitely it requires. That's why we in this automation have those specific storage packages. Because what does happen? In some cases, you have IoT devices, like you are managing your fleet, your truck. If you manage your truck, if you send data with the position every 1 minute, would be cheaply good enough, 1 minute, 30 seconds, and you're sending only 5 or 6 data points. You're sending the location of the truck, eventually the loads, the gas. So to each truck, every minute you receive 5, 10 points. When you go to the factory floor, that's completely different. If you have, for instance, a furnace or a factory of cookies or any kind of sweets, you have those furnaces, and it's not uncommon that that furnace has 1,000 measurements that want to read every 1 second. One day has around 8,000 seconds.
Yes, yes.
So if you have 1,000, 8,000 points, you are getting 8 million data samples every day. So in 10 days, you have 800 million data points.
Yeah, that's a lot of data. Eh?
So when you do the math, you see you can achieve terabytes of data very, very quickly. So when you go to really do lots of automation around factory data, when you try to do the basic simple approach, oh, let's read my points, put in a SQL table, it will fail, because we achieve hundreds and hundreds of millions of records very, very quickly. So when you go to the IoT applications for industrial data, you always need the concept of a time series database. So many of your listeners, they may be users for that term. Those that are not yet definitely should be. The generic name for that is time series database. And essentially is a way to store data that we have a huge amount of data, and that data has always a timestamp and is typically sequential. So when we have that kind of data that has always a time and it's typically sequential, and we have many and many samples with the same time. So now at this time, all those 1,000 values, they are all connected with that same time. You can do some optimizations to store and recover that more quickly. So there are many independent companies that they sell time series database, and the big cloud providers now, Azure, the Google Clouds, Oracle, they have in their cloud infrastructure specific options to store time series data, or they call stream data also. So they have that infrastructure available. You just need to make sure to leverage that for planning your data.
Oh, okay, that's interesting. That's interesting.
Yes.
Now, I want to move to the issue of connectivity. You know, communication, moving the data around. I want to hear what's your take on what the role of the MQTT Sparkplug is in this whole ecosystem.
What does happen with the IoT protocols? First of all, you need something that's light, because you need to save communication bandwidth. Many of those devices, they're still using 3G, 4G connection. Allegedly 5G, when it's really deployed, will solve the bandwidth problems. But right now, bandwidth is an important thing to consider. So you need a protocol that's very light. That's where MQTT come in place. But then the Sparkplug B extensions solve another problem. On the IoT world, what's beautiful on the IoT, you can add or remove devices very easily. On the previous programming model, you have to have everything planned. So each point you need to add was months. if you really have an IoT solution, you should be able to add and remove devices very easily and very quickly. But to be able to do that, we need to have protocols that can identify very easily that new resource is available. You need also very easily to put that data in an asset model. By asset model, I mean, what is the path, the name for this data? Like factory 1, rule number 2, sensor number 5. You need to be able to create those paths and those connections to the data dynamically. That's what MQTT and the Sparkplug B allows you also to do.
Okay.
So the main importance of adopting that is not only because it's the bandwidth, but also because they're much more suitable when you are dynamically modifying your data model.
Oh, okay. And
so
yeah,
go ahead.
Go on.
No, I'm saying they are really enabling the IoT solution in that sense. Because if you had the IoT devices that you can very easily add new devices, add new points, but you have to go to an old style programming tool and to do brute force mapping of everything, it's not really an IoT solution, you see.
Yeah, exactly. Yeah, so and what about standards like OPC-UA? Where do they fit into that?
This OPC way, it's trying to solve another problem. We have in the industrial floor hundreds and hundreds of protocols. Still today, when I started doing that 2 decades ago, we have around 300 communication protocols. Each manufacturer, they created their own communication layer. It was a way for them to protect themselves. But even now, there are around 50 to 70 communication interfaces that are used on the factory floor. So the idea of OPC UA is to be to the external applications. They only will see the OPC UA interface, and the OPC UA servers, they will translate those requests to the specific protocol the device is using.
Oh, okay.
So when they put the standard for the OPC UA, they did also have the specifications to do asset modeling, to define the namespaces for the tree. But the adoption of that to be realistic, it's very, very slow. So for the data model, they are really using the standard MQTT brokers or asset modeling of generic asset modeling tools. So they are not really, at least right now, that may change the future, using OPC way to model the data. But the role in OPC way is really growing a lot, is to be that common interface to hide all the underlying protocols from your main application. So your main application talk to an OPC UA server, and the OPC UA server will grab the data using the specific protocol.
Oh, yeah.
And another reason that lots of talk around OPC UA right now, this concept of have OPC to simplify the connection with the fields, we had for many, many years. But the previous standard that was OPC GA was not secure. Or let me rephrase that, was very complex to add securities. And was very, very complicated if you try to access through the web. So the OPC UA has a big role also in the IoT, because it simplifies the security and also is supporting connections that can go very easily through HTTP, through web protocols.
Okay.
That's why there is a big migration now from standard OPC to OPC U8.
Yeah, absolutely.
So you can have the security and you can access through the web. The previous standards, you could access only inside the factory. It was very complicated to access from the clouds.
Oh, okay. All right. I see. It makes a lot of sense. Now, once you've collected all of this data, now I'm gonna move on to the applications part of it. What sort of applications can you build for plant flow analytics? I'm going to start first with the real-time metrics, because that's something that is very important. What sort of real-time metrics can you actually build?
Well, well, there is a very popular saying that if you don't have a number, if you cannot measure it, you cannot optimize it. I don't know if you heard that before, but it's a very old popular saying. And when you go to the specifics of metric, if it's manufacturing or if it's a continuous process like pipeline or like a chemistry, they merge for quite a lot, okay? But let's start giving some examples on manufacturing. One example, it's very easy now to do implementations of OEE, overall equipment efficiency, because on the past, you have to deploy specific PLCs, you have to deploy applications, the data was not compatible. With the IoT solutions now and the gateways, you don't need really to touch your infrastructure. You can deploy some very easy IoT gateways to collect that data, send to the cloud, run the algorithms on the clouds. So you can very easily nowadays create those operational dashboards where you see all the status of your production lines, what is stopped by maintenance, comparing that with the planned workload for that equipment. And you can do early detection of maintenance. Man-in-man devices, before they need to go to maintenance or before they break, they have difference on performance. For instance, if it's a heater, you need to put more current to that heater. And if you have that information in real time, you are able to know and prevent that. Some IoT systems that were deployed, they paid by themselves on the first month of operations, because some equipments that were very priced equipments, or it would be a big problem because to put that equipment maintenance could stop a line for lots of time. With that early detection that we have, when you have the mesh in real time, you can avoid that. And so some of the equipments that I'll talk about and some production lines that we need to stop can go from hundreds of thousands of dollars. In some cases, can go up to the million. So when they do the investments, 50K, 100K, 200K, $300,000, depend on the system to put some IoT package, sometimes can be much less than that. But the point is, when you compare the time, the money you are losing when those equipments they break, or when you are operating line not with the proper performance, or we need to stop that line because when we have not the material. The reason there is lots of people to installing real-time metrics on the factory floor, it's not only because it's cool. Yes, it's cool, it's fancy, everyone's talking. There is also that professional pleasure aspect.
Yes, yes.
That the engineers, they are willing to do that for professional pleasure. But the good news, they are getting the budget approved because they can very easily show the payoff for the system.
Oh, okay. Yeah, I see.
They show, okay, give me 50K to do this little automation here,
Yes.
and in 1 year, I will save you 500K. So it's a really the best of the
Yeah.
worlds, because the engineers, they like to go after those new solutions, because of course, we want to do the best on your daily professional life. It's good to work with new systems, to be learning. And in
Yeah.
this case, it's the company has a huge benefit. So both on the professional pleasure and making money for the company, any type of real-time metrics that you can do. And also the real-time metrics is the first step to do the machine learning and the digital twins and the more advanced analytics.
Oh, okay. I
Because
see.
what does happen, there is lots of talk about machine learning, where the system will automatically help you to put the system the best performance, or advanced AI tools. But those things, they are not really magic tools. You can, okay, let's put this machine learning software in this factory,
Yes.
and he will grab the data. No, we are not, they're not that advanced yet. They're not people yet that walk them by themselves to the factory searching for the data. So the first step to be able to put those more advanced tools that can even bring even more efficient and cost reduction, you need to have a good real-time metrics to know your process.
Oh, yeah. I see. Okay.
When the machine learning tools and the AI tools will be deployed, they need to have some minimal guidance that the experts on that process, they need to do initial teaching to those systems. They cannot start from scratch. So you need to have a good understanding on your process to know where those other technologies will be applicable.
Oh, yeah. Well, you've already
So
touched.
you need
Yeah.
to have a few months, in some cases a year of operation with good real-time metrics, collecting the data, being able to understand what are your key parameters, to then apply the machine learning and the AI on those key KPIs. But you
Okay.
need to get holds on those key performance indicators first. You need to have that automation, you need to understand that. If you try to do, oh, let's do a machine learning process here and don't have the base automation good enough, it'll be a waste of time, money, and frustration. Because your operations, they are not yet visible and automated enough to benefit of other class of applications.
Okay. Yeah, that's interesting.
Before we go to machine learning or AI, the basic infrastructure of the data to have the proper metrics, define the KPI, it's the first level of investments the company needs to do, because some projects we see that they fail. They try to jump right away to machine learning or to AI, but they don't know enough for their process, and they don't have enough good real-time data acquisition.
Okay.
I think that's really an important concept I was trying to put emphasis with you and your people following us. because there are lots of marketing and people talk about AI applications, machine learning, and all those new cool projects.
Yes, yes, yes.
But one thing that we must keep in mind, those tools are not really magic. To be able to properly apply and define which variables are going to monitor for the machine learning optimization, on what you want to accomplish with higher level of optimization, you need to have some basic knowledge about your process. You need to have reliable data acquisition in place. So one thing that all companies, they should be doing now, if they don't have yet, you have huge benefits even before you go to those more advanced applications. If you just deploy in your factory the basic real-time monitoring of your key variables. So if it's manufacturing, you can do an OEE application to pick up the status of the production line. If it's some sort of chemical or continuous process, you can put the sensors for the batches or for the temperature, water, whatever. But when you have those real-time data giving the true visibility of your process, you have right away a benefit because you're able to detect bottlenecks that you didn't have. And also, very importantly, you'll be able to define what you need to do to your next IoT project. So you really should split that in two phases before you go to those AI applications.
Okay. All right. Okay. So maybe for the benefit of some of the audience who are not familiar with OEE, can you give us a description of what the overall equipment effectiveness is, and what is its importance in plant flow analytics?
Sure. Essentially, when you have, that's a concept that apply to almost all kind of production lines. Most of the manufacturing, you have your production line, and that production line, you have a few machines working on that production line, and there are three key parameters that in almost all factories you want to monitor. That one of them is connected with the quality. You need to know how many good parts or bad parts you are putting out. The other one is regarding how much stop time or how much availability you have on that machine. If you need to put out one machine of a part of production line for maintenance, you want to know that. And finally, the performance means when the machine are working, if that machine of that production line is working with the expected as fast as possible. So when you pick up those three metrics, the quality, the performance, and the availability, that all those the overall equipment effectiveness, or OEE, and a very standard for you to apply in your production line. The type of sensor you need to have, the calculation you need to do, all of that is very standard and easy to implement nowadays. So it's like a traditional manufacturing line. That's for sure a great way to start your IoT.
Oh, okay. Yeah, so interesting.
And to start, because after you have the OEE in place, you have the vision on how your line is working. Then we go on the second step, because that metrics may show, okay, my overall performance is only 75% because I have a huge stop time, a huge time the machines are not available. Okay, now it's the first step to start to ask why. So it's very common word in the industry in general, and not only in science, everything. You only can improve what you can measure.
Yeah, absolutely. Yeah, absolutely. Okay, so you have already spoken about machine learning at length. Now, I just wanted to get your thoughts on the application of machine learning in the plant flow. Are there any interesting applications of machine learning that you've seen so far?
Mm-hmm.
Practical applications of machine learning.
Mm-hmm. Well, one thing we need to, there are two areas that machine learning can be quite useful. I'll give an example in manufacturing and another example in continuous process. Okay, you start in manufacturing. Going back to the OEE that you need to increase your performance, one way to do that is to better planning for the maintenance. Because when you have an unscheduled maintenance, it's always more costly and time consuming. When you decide to fix any piece of equipment, when it's not performing well or when it's broken, sometimes you even may lose some parts that are very hard to replace. And after you have your OEE, your monitor variables, you'll be able to detect key variables to put on the machine learning that they can measure how efficient that equipment is performing, to be able to detect the maintenance before the equipments break or reach a point of too bad performance. For instance, if you have a heater, you can measure how many current you need to put.
Yes.
And some equipments, with the time, you need to put more energy, more watts, more current to achieve the same level of heating on that device. And it's very hard sometimes to do that planning based on the documents of the machine, on the machine documentation, because sometimes the machine is a used machine or there is many factors in place. But if you do the proper machine learning, that you monitor for the performance, for the operations, over time, you're able to detect those bottlenecks on your equipment before they reach the points. And it's not based on the technical specifications that who knows how accurate they are. When you do the machine learning, the numbers that are popping up to you are based in the real performance of the equipment. That's the real thing. So whatever is above or beyond the manufacturer specification, who cares? What the machine learning is giving to you is the reality of your equipment. Okay.
Yes.
And if you have continuous process, things like PID optimization, regulation of when you have your set points, how you should set up your proportional control for the high level optimization. That's another example that kind of machine learning helps a lot. But that said, you need to have a really good understanding to pick up which variables you want to monitor, which models, what you want to achieve.
Yes.
One problem with machine learning, when they talk AI, machine learning, just produce the data, I myself from the beginning and some of my clients, they thought that was just a little too magic. Oh, let's get the data and okay, but you need to select what you're going to measure.
Yes.
You need to define what you understand as a good result. So the first step of the machine learning is not learning through the data. You must be the teacher for that program, teaching the basics on which variables to look for, what you consider a good performance. So then the AI tools can kick in. But you really can have very good gains with that, because there is no other thing that will replace that. You can achieve some performance, you can find some results after you have that in place that no previous procedure would allow you to achieve that result. So the reason machine learning and those AI tools, they are such a big, because it's really a new step.
Yes.
On productive, on meditative maintenance, that are being able to produce results that are really beyond the previous technologies. So when they work, you have real gains. That's why most of the companies, they are moving to that, to see how that technology can be applied or not in their production lines.
Oh, okay, interesting. Makes a lot of sense there. Now, what about the digital twins? What are your thoughts on using the digital twin technology for operational intelligence?
Well, let's start to review the concept of digital twin, because it was a great name from the marketing point of view. But at the same time, sometimes it puts a little more complex around a concept that's pretty very simple. That's pretty much to have a model, the representation of your device, of your machine, of your instruments in your computer. So the name digital twin was pretty much a copy, a virtual copy that will emulate the behavior of your machine or of your sensor. To give a very simple example, if you have a temperature sensor that's based, when you put 25 degrees, it put out 5 milliampere. And when it's at 50 degrees, it put out 15 milliampere. So let's say that's the behavior of your temperature sensor. If you create a function block in your computer, a little programming block, that when you input 25, it put out 50 milliampere, you create the digital twin of that sensor, okay?
Yes.
And when you make it grow to put your full instrumentation, your machine, there are many and many applications why having those model it's important. And I will list all those applications. One first application is even before you start a production. Nowadays, you are planning your production line. You can run the full simulation of that production line using the digital twins. That's the first basic application. The second one that's more typical for operational intelligence, as you did mention, is you put the proper sensors so you can compare what the line is doing with your models. So you run side by side the line and the model,
Yes.
getting some data from the line. And you have a full circle there, because in one side, it helps you to refine your model. In the other side, this refined model can feed back for the line and detect some anomaly when an equipment is not working properly, when the efficiency is doing. And so that process is also a learning process by itself, because sometimes you find out the model was not precise and you refine the model. Sometimes, oh yes, the model was precise, there was a problem in the line. So that's a continuous process, but over time, as the models become, and the digital twins, the representation, they become more reliable.
Yes.
You really, over time, the gain starts to increase, because you're going to have better models, better digital twins, and you are able much more to allow the model give information about the line, and not the opposite. So you need to prepare to have some investments on that. It's not sometimes in the first week you have the benefits, because you need to do the validation of your models.
Okay, yeah.
And that can happen quickly. That may need longer time. But in some points, the digital representation of the device will be good enough that you'll be able to find out potential issues on the line from your digital twins. And when you reach that phase, you can go to the next one and the final benefits. That's when we start to planning modifications of products, supplies, machinery, using the digital model. So after you have your model is stable, that's already giving feedback for potential problems in the line. Now we have also the benefits to use that as a planning tool. If you want to modify some process, to modify some machinery, to modify some material you are using, you can do that validation with the digital twins before deploying.
Oh, okay, interesting. That's very
Yes.
interesting. Okay, so now.
And you see, go ahead.
Sure, go ahead, because I was about to wrap up.
I'm just saying that again, everything's starting to have a good real-time monitoring of the process. Because to be able to fine-tune those digital twins, you need to have your real-time data acquisition in place.
Oh, okay.
Let's go back to that basic that I was explaining to you.
Oh, yes.
So to leverage the digital twins, you also need to have that real-time data acquisition in place, first of all.
Oh, yes, yeah. Makes a lot of sense. Okay, so now to wrap up the conversation, I want to speak to you about Tatsoft. Could you please tell us about Tatsoft? What role do you play in the industrial ecosystem? And also, after that, I want to speak to you about your new version 9.1. So could you please just give us a brief?
Sure. Well, I've been working on industrial automation and data acquisition for around 3 decades. And around 8-9 years ago, we're starting to talk a lot about Industry 4.0, a little bit about IoT also, but frankly, 10 years ago, it was more Industry 4.0 than IoT, the term by that time, but similar concepts. And what I realized based on my experience, that the most of the software platforms, the tools to create applications, they were previous generations of technology, adding some functionality on the top. And that does not work well enough. If someone in your audience is old enough to know DOS, you will remember that when you did from DOS to Windows, we had to recreate the applications. We could not pick up a DOS package and try to modify only the user interface. And a problem I saw a few years back, and they're trying to create IoT applications, 4.0 applications, but with tools created on the previous generation of technology. And the things are not really working very well. So when I create Tatsoft 9 years ago, I'm the company founder and CTO, was to create a new platform from scratch, from a blank piece of paper, to create distributed applications, IIoT, Industry 4.0. So the goal for Tatsoft was to create a platform, a framework, to allow system integrators and end users to create their solutions. Because with the proper platform, you can put a solution running from days to weeks, months only if it's a big, complex project. But if you don't have the proper framework, you don't have a configuration tool to allow you to create your solution very quickly, you can take from months to years sometimes to deploy properly your projects. And so that's Tatsoft, and we're just releasing now in January the training class, the online training for our version. We're just releasing the FrameworX 9.1. So if you go to the Tatsoft website, we're putting a fresh new release right now.
Oh, okay. Any new features with the version 9.1? Any interesting features?
Well, two features that are quite interesting. One is regarding the user interface, because some displays, like you have the diagram for a machine, when you change the resolution for your device, like a computer to iPhone, you need just to resize the diagram because it's a drawing of the machine. But if you're looking, for instance, KPIs with trend charts or numbers, if you look to your computer and then go to iPhone, you want us to reposition the blocks and reposition the elements to be responsive to your display. So one challenge on real-time automation, that some screens you just want to resize proportionally, and some screens want to be adaptive or reactive to reposition the elements. It's like a dashboard with KPIs. And we have that feature now automatically in our package. So when you are defining the main application, the many displays, the many user interfaces, you can very easily select which one will be responsive, that will reorganize the elements dynamically based on where you're looking at displays, and which ones you keep the proportion of the drawing. So it's very easy to create applications that will be responsive in whatever kind of device you open to look the data. And they call that responsive dashboards. And that's one big feature. And the other one that I talk a lot, we put lots of features for that protocol MQTT. That it's a light protocol that lots of industrial devices are using. So you have the client side, you have also the server side. We put a very complete solution around that technology, so you don't need to go after third parts. We have in our platform everything that we need. And the last one, just remember, they like also our ability to do custom code, because for the more advanced applications, you want to write your own logic. And we allow to do that in Python, in C# and VB.NET. So you have 3 choices of language in the platform to do that advanced customization. I think those are the 3 ones in the last 2 weeks that we put out the release, the feedback that we're receiving. Those are the top 3 that are receiving more good feedback.
Oh, okay, interesting. And it's available for trial. You've got a trial version?
Oh, yeah, definitely.
Okay.
When you go to the Tatsoft website, you have the formula. You can request a full functional version to play with.
Okay, all right. Yeah, so that brings us to the end of this discussion. Thank you so much for joining us today.
My pleasure.